Let us learn more about quadrilaterals. So far we have seen that quadrilaterals are any four-sided figures. All four-sided figures are called quadrilaterals. Or you can say that if four non-collinear points are joined, then the figure so formed is called a quadrilateral. Now in this video we are going to try and understand if these quadrilaterals can be classified or can we find any types of quadrilaterals, and we are going to do this by imposing certain criteria on these edges. So let us say that the first criteria which we impose is that at least one pair of opposite sides are parallel. At least one pair of opposite sides are parallel. What would happen to a four-sided figure if you impose this criteria that at least one pair of opposite sides are parallel? Now it might take such shapes, right? So I am drawing these two opposite sides parallel to one another, and let me join the other two sides. So this follows our criteria, right? I can even draw the longer side on top, the shorter side here down, and join the other two sides. Okay, it's not a straight line, I'll make it a straight line. Yeah, this is also satisfying the criteria which I have mentioned here. And one more could be, let the parallel sides be vertical to one another and the other two sides are joined. So these two sides are parallel. So this also satisfies our condition that at least one pair of opposite sides are parallel. And what if it is like this? This is the parallel side and this is the other two side. And it so happens, like if I draw a perfect figure, here, it so happens that the other two sides are also parallel, but how does it matter to us? Our condition is still satisfied, that is one pair of opposite sides are parallel to one another. So these are the different shapes which a quadrilateral could take if we impose these conditions. And these are popularly known as trapeziums. These shapes, these four-sided figures, where at least one pair of parallel opposite sides are parallel, are popularly called as trapeziums. And we have a special type of a trapezium where the non-parallel sides, that is these two sides, are equal in length. This is a special kind of a trapezium because our criteria doesn't say that. Our criteria just says that at least one pair of opposite sides are parallel. But if it so happens that we have a trapezium, and in that trapezium, if the non-parallel sides are equal in length, if they are equal to one another, then we call such a trapezium as an isosceles trapezium. The name follows from the isosceles triangle, where the two sides of the triangle are equal in length. Here also two sides, but it so happens that the non-parallel sides are equal in length. So this is just a name, isosceles trapezium. And now, having looked at what trapeziums are, let us explore if there are any specific properties which a trapezium would follow. Since we have identified the shape or defined a new shape of a quadrilateral, let's see if there are any special properties which a trapezium would take. And the first property would obviously be the angle sum property, because this is a property which any quadrilateral would satisfy. Right? The angle sum property is followed by any four-sided figure, that is the sum of the angles. How many angles are there? There are four angles in any quadrilateral. We have 1, 2, 3 and 4 angles. All the four angles would add up to 360 degrees, right? So this is obviously satisfied in a trapezium also. And what can there be any other property? Let's see. Let this be a sample trapezium. Let me call it A, B, C and D. And if I join the other two ends, that is AD and BC, since AB is parallel to CD, I can look at AD as a transversal, right? AD can be looked at as a transversal. And similarly, BC also can be looked at as a transversal of these two parallel lines. So what happens in the case of a transversal? These two angles would add up to 180 degrees. Why? They are on the same side of the transversal. They are called as the co-interior angles. So we have angle A plus angle D is equal to 180 degrees because they are co-interior angles. They are the angles which fall on the same side of the transversal. And similarly, we would be having angle B plus C will also be equal to 180 degrees. So adding these two, you would get angle A plus angle B plus angle C plus angle D would be equal to 180 plus 180, which is 360, our angle sum property. So the only extra property which we could now identify in a trapezium is that the sum of these two angles, angle A and angle D, the angles on one side or the angles on the same side of a transversal add up to 180 degrees. So I leave it to the viewers to think of if there are any other properties, but at the same time, I would like you to ponder upon the fact or whether there are any properties for this trapezium, for an isosceles trapezium. Of course, these two properties would be satisfied because an isosceles trapezium is also a trapezium, but ponder upon whether there is any other property before you look at our other video, because our other video would be explaining you in detail that special property which an isosceles trapezium would have. Thank you. We hope you understood.